Good day, class. We are still on Module 1, Mechatronics Engineering, pero naanata sa Lesson 4. That is all about actuators and mechanisms. By the end of this lesson, you will be able to define what are actuators and mechanisms, then discuss the principle of operation of pneumatic, hydraulic, and electrical actuation systems. So these are the types of actuation systems. And lastly, we'll be able to identify different mechanisms and discuss their working principles. Previously, we discussed about sensors and transducers sa last meeting. This is our typical diagram of our mechatronic system, and we are already through with the controller. So our controller is considered as the brain of our mechatronic system. This is where we are going to input our instruction in a form of a code or a programming language, and then we are already through also with the sensor. The sensor is responsible for measuring physical quantity from our plant and converting it into electrical signal, and then it will be processed to our controller. And the ang trabaho pod sa atong sensor is to monitor the status or condition of our plant. And this time, we're going to discuss the component that connects the controller and the plant, and we call that one as the actuator. The purpose of the actuator is to convert the electrical signal from the controller a into something that will alter our plant. It could be a mechanical motion, it could be heat, or etc. So actuation systems, they are the elements of the control systems which are responsible for transforming the output of a controller or control system into a controlling action on machine or device. Examples, we have hydraulic, pneumatic, mechanical, and electrical systems. Okay? So gikan sa control system, mo-output siya og electrical signal, no? So mura siya mo-act as an input, no, sa atong actuator. So mohatag siya og input sa actuator nga okay, mao ni siya ang desired nga imo ang ihatag ngadto sa ato ang plant. Since electrical signal na siya, and let's say for example ang atong plant kay kanang iya purpose is painiton, okay, painiton ang ato ang sinina. So ang kinahanglanon nato dira nga actuation system is ang kanang heating element, no, kay heating element. Therefore we are going to convert the electrical signal from the control system into an equivalent kanang thermal energy para painiton, and in order to remove the moisture of our cloth inside our plant. Okay, so this is the actuator in a feedback control system. This is the typical diagram of our feedback control system. Why is it called feedback? Because we have here a return signal, no, through the sensors. So our actuator is typically located between the controller and our plant. So kani siya figure sa right, this is a typical mechanical and hydraulic actuators, no, for our disc brake applied sa atong mga kuan automobile. So starting with the brake pedal, so kung mo press ta dira, of course that movement, okay, or that action is conveyed with these mechanical linkages, no, and with that naka-convey siya padong sa atong master cylinder. So inside the master cylinder, unsa naman pud ang nagpa-convey sa movement padong sa kaniyang brake pad. So ang nagpa-convey ana sa movement is the kanang brake fluid. That is why from mechanical then mo ngadto siya sa hydraulic actuation. So with the brake fluid, makonvey na siya, moagi na siya along this brake line, and then siya na ang responsible to open and close, or to loose or grip the brake pad, thus performing its function. Okay, so muna siya ang typical example sa ato ang actuation system, no. So types of actuation system. Let's start first with the hydraulic systems. So a system that uses pressurized liquids such as oil to convey movement, and then it can be used for higher power control devices, but they are relatively more expensive. Mo lang iya drawback, no. And another one, the hazard associated with oil leaks is also a drawback of this system. That is why kailangan nga ang pag-designer, no, dapat kanang leak proof, no. Okay, dapat walay mga leaks, and then it is usually driven by an electric motor to perform its task. Again, kung magamit ka hydraulic actuation system, dapat pressurize imong liquid nga gamito, no. Dili pwede liquid under atmospheric pressure because you cannot convey a movement for that particular condition. So this is our typical hydraulic power system. We have here our oil storage or the liquid storage. We call this one as the sump. So this oil is used to convey the movement. Kay gigamit man siya as an actuator. So si oil, i-transport siya through this pump. And the pump is excited by the use of our motor. So gicoupled na siya. And as the oil leaves the pump, it enters the non-return valve. The purpose of the non-return valve is to direct the flow of the oil in one direction only, meaning dili siya mobalik. Okay, if mabalik siya, then it will cause damage, no, sa ato ang pump. And after that, it will enter again sa kaniyang gitawag nga pressure relief valve. The pressure relief valve acts as a safety valve wherein iyahang i-relief if ever mo excess na ang pressure sa atong oil. So if mo excess na siya sa threshold value, then iya siya ibalik nga to sa ato ang storage or sa sump. And then after that, from the pressure relief valve, it will go towards the output side. Okay, the output side. And we also have here, okay, along this line, we also have the accumulator. So the purpose of the accumulator class is to respond, no, to respond any pressure fluctuation in our system. So if ever sa output nato maka-experience siya o kanang mag-fluctuate ang pressure, so siya mo respond ana, siya mo answer niya na nga, siya mo hatag ana nga kanang particular nga amount of pressure nga nakuwangan sa ato ang system. Okay, so example sa ato ang hydraulic actuation system. Example sa pumps kay ang pinaka center or importante diri nga device is kanimang pump, no. So ang output sa atong system nagadetermine pod sa kanang type of pump nga imong kanang gamiton. So I have here some examples of hydraulic pumps used as actuators. So we have the first one is the gear pump. So it uses these two gears, no, in order to increase the pressure of the fluid. And then the second one is the radial piston pump. So it uses the circular motion of this piston arranged radially. So mosulod dira isak in ang liquid and then ibuga pod ari sa outlet port. And again, this arrangement increases the pressure of our liquid. And these two are example of a positive displacement pump. So why is it called a positive displacement pump? Because for every rotation of this kind of typical pump, discontinuous ang ihang output, no, unlike mga centrifugal pumps or rotary pumps nga continuous ang ilahang output. So we also have the vane pump mo na iyahang structure, and then we also have the axial piston pump with swash plate. So mo na siya ang swash plate. So kada rotate sa ato ang shaft, na may misalignment, no, that is why ang kaniya siya mo move backward, kani siya mo move forward. So na ay nahitabong intake and then napoy outtake. So this is the outlet port, and in this mechanism napareis nato ang pressure sa ato liquid. Okay, so next is we have here the hydraulic piston cylinder actuator. This is the common hydraulic actuation system nga gigamit, no. So we have here the this kind of typical diagram of our hydraulic piston cylinder actuator. We have the piston rod, the rod seals, the piston and seals, then we have the retract flow and the extended flow port. Again, kailangan ang pag-design ni ani is silyado kay to prevent hazard from oil leaks. So unsa man niya pag convey og movement. So let's say for example, mara siyang input niya, no? Okay, input nga pivot point. So if we're going to kind displace this one, so we have your delta x. Of course, it will also this piston head will also displace by delta x. Okay, so since we have here the oil, so oil is considered or assumed as incompressible, no? So meaning dili siya makompress. So therefore, kasi oil motud pod ani niya kani siya entire body, and of course loose money mo move money ang piston rod relative to this case. Therefore, this output na pivot mo move pod siya with this displacement delta x. So therefore, from the input displacement na po tayo corresponding output displacement through the use of this oil. Okay, so next is pneumatic systems. So it is a system that uses compressed air to actuate the mechanism in a control system. The main drawback with pneumatic system is, however, the compressibility of air. So the same with the hydraulic system, kailangan compressed air ato gamiton. So a typical gas, pero mostly ang gigamit sa pneumatic kay air since air is available man sa atong surroundings, no? And then ang iya drawback lang is ang compressibility of air. So with the compressibility of air, it would take much time to convey, no, to convey movement kay kung ato i-press, no, ato i-compressed. So maglag pa siya, no. Let's say we have here nata diri ay kanang kuan piston cylinder arrangement. Okay mo na siya. So if we're going to displace here delta x, there is ato ang input, no, mag-apply ta og force dira. So naa diri ato ang air sa sulod. So kanatong air, of course, na pa siya compression, no, compression before pa niya i-convey ngadto sa output. Therefore maglag pa siya due to the compressibility of air. Unlike sa hydraulic nga, i-press na to diri and since oil is assumed as incompressible, so therefore on time or on the spot ang ihang pag move dayon, no. So makahatag din siya og direct movement sa ato ang output. Okay, this is the typical pneumatic power system. So the same thing na gyapon siya diri ay storage, no, storage, so air storage, and mo enter na siya una sa filter. So iya i-filter ang mga contaminants or mga impurities nga present sa air. Kailangan siya i-filter in order to avoid damage sa ato ang system, any corrosion or possible rusting. And then next is musod siya sa silencer, and then after that mga na siya sa compressor. So si compressor ang responsible for the circulation and also responsible for increasing the pressure, no, para ma-compress siya by the definition of our pneumatic system. So si compressor is of course connected via motor to perform its task, and then as it leaves the compressor, it enters the pressure relief valve. Again, this is a safety device in order to regulate, no, the allowable pressure na kailangan na sa ato ang system. And after sa pressure relief valve, it enters our cooler. So unsay purpose sa cooler? Sa pag-enter man gud sa ato ang air inside the compressor, of course the pressure increases as well as the temperature. So pressure increases as well as the temperature. So since in some applications dili ta need nga init ang ato ang i-flow diri ang kanang gas, no. So kailangan relatively at lower temperature, so that is why aton siya i-cool down, but still at higher pressure na siya. Okay, but still at a higher pressure. So mag-agi sa cooler, and then another filtration device, filter na sad nya diri pod sa cooler class. If naapay mga naapay moisture nga present, so mo condense pod di para pure gid nga air ang mo sulod sa ato ang system. So this is our output, and along the output line, so the same with the hydraulic system, na siya accumulator dito so diri we also have the air receiver. Again, ang main function sa ato ang air receiver is to respond any kanang pressure fluctuation sa ato ang system. Okay, so we have here several examples of air compressor used as pneumatic actuators. Diba, diri sa ato ang kanang kuan diagram sa ato ang pneumatic power system, importante ang ato ang compressor. Mao po na siya nag-determine sa performance sa ato ang actuation system. That is why pwede ka makapili na rin, no? You can have this single acting, single stage vertical reciprocating compressor. So single acting, input output one direction lang, and then single stage, so usara gamit dili duha compressor, and then reciprocating iyang manner, so pataas then pababa. So example sa atong reciprocating compressor is the piston cylinder arrangement. We also have the rotary vane compressor, mo na siya yung structure, and then we also have the screw compressor. Pero daghan pa kani siya mga example sa mga air compressor. Next is mechanical actuation systems. So this is a system that uses different varieties of mechanism in conveying movement. So mechanisms are devices, so these are collection of machine elements in which can be considered to be motion converters, in that they transform motion from one form to some other required form. So since ang mechanisms kay comprises of machine elements, so unsa may mga typical examples sa ato ang machine elements. So we have here, the first one is the linkages. So these are rigid bodies, no? Kaning blue, green, red. So di na sila flexible. That's why it's called linkages. Ikada is we have cam. So the cam here is kani siyang marag itlog ug porma, no? And then we also have the follower. So this is the follower. The purpose of the follower is to receive the motion from the cam. So here, na-convert niya ang rotary into linear movement, but of course ang iyahang behavior diri as a pag-move up and down mag-vary with time depending upon the profile of the cam. And then we also have the gear drive and the belt drive. So both the gear drive and the belt drive are used for power transmission and also for torque and speed conversion. Okay. Examples of mechanism. So we have here, the first one is the slider crank mechanism. So why is it called a slider crank? So we have here the crank, kani ang red, no? So from rotational motion sa ato ang crank, and then we have here the slider, kaning gray. So muna siya ang slider. So from rotational motion into linear motion sa ato ang slider. So mag-move ni siya back and forth diri. And we also have the 4-bar mechanism. So natawag na siya 4-bar mechanism because it consists of 4 rigid links. So we have link 1 ang blue, link 2 ang green, then link 3 ang violet, and link 4 is kaniyang iyahang frame, no, kaning brown. So ang kanide ato ang slider crank mechanism is a modified 4-bar mechanism. So rotate ni siya as the crank 1 or this link 1 rotates. So napoy corresponding movement sa ato ang links 3 and 2. And then we also have here the quick return mechanism. Nindot kani siya mechanism, no, kung inyong na-observe ang iyang movement, kung padung siya ngadto, slow ang iyang movement ato, no. However, if moadto na siya, very quick. That is why it is called a quick return mechanism. Kani siya gigamit siya nga mechanism sa ato ang sa ato ang shaper nga machine, kani siya. Here naapod tay gitawag nga scissor mechanism, no. So these are rigid links arranged in a cross fashion. So naka-cross siya. So kani siya, if imo na siya i-move downward, so mo compress na siya, no, meaning mo gamay ang iyahang displacement. And then kung imo pod i-move toward each other ning kani mga cross links, so mo extend pod siya or mo expand pod siya. So nindot ni siya for lifting heavy objects or any objects. We also have the cam mechanism. So the cam, mo na siya ang cam kaning blue, and then connected sa ato ang shaft. So as the cam rotates, so mo cause siya og motion sa ato ang follower. So this is our follower. And as you notice, ang cam nato is eccentric siya, no, meaning wala siya sa center point. Kaya if na siya sa center point, so walay motion nga na-create sa tong follower. So gituyo ni siya nga eccentric siya so that we can convey motion sa ato ang follower. And here we also have the Geneva mechanism. Ang output sa ato ang Geneva mechanism is from continuous rotation sa ato ang driver, so kaning gray, into an intermittent motion sa ato ang Geneva wheel by this kaniyang pin, and we also have here some slots. So naka-decide na siya so that ma-convert na to ang continuous rotation sa atong driver into an intermittent rotation sa ato ang Geneva wheel. Okay, next proceed ta sa electrical actuation systems. So it is a system that uses electrical devices to control the plant. Unlike sa mechanical nga mechanism gigamit, sa hydraulic mga liquid ang gigamit, then sa pneumatic ay gas ang gigamit. Diya sa electrical, syempre electrical devices pwedeng gigamit to convey motion or any other else. So examples are switching devices, solenoid type devices, and drive systems. So example of electrical devices used as actuator, pinakasikat ang relay switch. Next is ang solenoid actuator, mo na siya ay ang purumano, and of course ang sikat si DC motor. So si DC motor kaniya yung output shaft, imo ni i-connect to frame or other kanang mechanism, so maka-cause siya og motion. Again, ang gi-input diri is kuan electrical signal. Okay, so we have here one example of electrical actuator. Pinaka common is the solenoid actuator. This is the diagram of our solenoid actuator. So a solenoid uses electricity, so gikan sa atong electrical connection. And then musod na siya, and inside our solenoid we have the coil winding, no. So these are coil of conductor. So once natay electrical signal nga mosulod, of course ang kaniadto ang coil winding mo create na siya og magnetic field, and with that magnetic field, so it enables the plunger to move forward. So move forward, therefore from the electrical signal natong gi-input diri na-convert nato into displacement. So therefore we convey movement through this plunger. And once ato na po i-disconnect, no, so kung ato i-disconnect, meaning ato i-cut off ang electrical signal, so nata diri a return spring daw is used to retract the plunger to its initial position. So inside our solenoid actuator, nata diri ay return spring. So man siya ang return spring, connected na siya sa plunger. So once i-de-excite na or kuhaan na nato electrical signal ang ato ang solenoid, so ang return spring may mopabalik sa plunger sa iyang initial position. And with this arrangement, na-convey nato, naka-convey ta og motion through this solenoid actuator. So it uses the electrical signal. Next, we also have the brushed DC motor, and we also have the brushless DC motor. So mo na iyang diagram. So nagkalahi gini sila, no. So gitawag ni siya brush DC motor because it has commutator, and within the commutator, of course, na dry mga carbon brush. So ang atong DC motor need na siya maintenance, kay kung mahilis na, so na wear and tear sa iyang carbon brush, of course kanang imo na siya alisdan, no. So subject for replacement. And then manotice po nimo nga brush DC motor na siya kay naay spark diri sa kanang buho, mag spark na ang kanang carbon brush. And kani siya relatively kanang cheaper compared aning brushless, kay of course ang iya design simple ra, gamit ra siya og kanang permanent magnet and coil winding. And then kani pod siya is for kuno kanang pang rugged na application, no. And then for brushless DC motor class, wala ni siya commutator, no. Wala commutator, so naalan siya permanent magnet, so kanay sa atong diagram. And then within this permanent magnet, I mean sa outside din niya is electromagnet, and then sa inner niya is kaning field magnet. So field magnet, it could be a permanent magnet or another electromagnet na pod. And this one, it uses the kuano, it uses the Hall effect. Okay, Hall effect na kuan principle in order to rotate this entire thing. And then kaniya apod ato ang brushless DC motor class, gigamit ni siya no, gigamit ni siya sa ato ang mga drones. So kani siya kay simple yan design, wala mga sparks and then very lightweight pod, but makaproduce siya og enough thrust. Okay, and then we also have here the synchronous motor. So this is an AC motor. So ang iyahang input na electrical signal kay alternating, and then this is relatively cheaper compared to mga DC motor no, with same size. And then kani siya is for kanang kani siya pang rugged ni siya no, so pang rugged ni siya. And then nga pod tay servo motor. So mo ani siya ato ang gamiton po sa ato ang project. Kani siya servo motor mo ni kani pwede ni siya ma-hook sa ato ang Arduino motherboard, and then maka-program ta ani niya. So si servo motor, iya function no is you can set kung unsa lang angle ang pag-rotate sa ato ang output shaft. So this is the output shaft. Output shaft. Ang kani siya ma-program ni nato nga okay, rotate lang by 30 degrees. So we can program that one. So 30 degrees lang. And then we also have here the stepper motor. Mo siya ang stepper motor, dagan kani siya og mga connecting wires no, because nakakuan mo ni siya na stepper motor nga 3 phase. So mag on off ta, and then I think na pod mo ani discussion sa inyo ang AC/DC no, katong mga arrangement sa coils na atay kanang Y na ay naka Y no, og nakaingani delta nga na arrangement sa coil, and naapod tayo katong murag naka Y, ay sorry, so naay naka Y ana. Okay, so mo daghan ni siya mga output nga mga wires no. And then sa stepper motor, andot ani is still maka-perform siya og rotation pero of higher resolution. So let's say ay mo stepper motor kay maka-perform siya rotation na up to 0.01 radians. So meaning ma-program na to nga mo-rotate at kanang 30 point, let's say this is the initial position, ato siya i-rotate at 30.05 degrees no. So iyan na ma-achieve given that ang iyahang resolution is up to 0.05 degrees. Nindot siya sa kanang mga CNC no. So kanato ang mga kanang inyohang kanang kuan sa ato ang CNC machine. So gamit kina siya og sa mga 3D printers. Kaya 3D printers exact gina ilahang kanang kuno positioning o pag dagan-dagan sa kana iyahang nozzle. So need na siya ning stepper motor. So again, ang advantage sa stepper motor kay na siya resolution no, para mas accurate ang ato ang rotation ani niya. Okay. And then ang another feature pod sa ato ang servo motor is ma-detect na to no. Ma-detect na to ayang position because nani siya diri ay sensor sa sulod niya, nani siya diri ay encoder no. So mani nice feature sa ato ang servo motor kana siya encoder. So meaning once nag-input ta sa ato ang servo motor og desired nga angle, let's say 30 degrees, so pwede pud ta maka-collect sa iya og information kung unsa na iyahang kanang position no, relative sa atong giset nga initial position. Okay, so kuan mara to sa ato ang mga kuano, ato ang mga actuators and mechanisms. I hope may na ni ani. And then a word of advice from Romans, and we know that for those who love God, all things work together for good for those who are called according to His purpose. And then again, same ra gyapon na to ang reference, William Bolton, Mechatronics, Electronics Control Systems in Mechanical and Electrical Engineering. So thank you for for watching, class. May God bless you.